Good afternoon. Today we are doing our last objective in Unit 4, CO28. I can calculate simple and compound interest. So we talked about calculating the tax on your dinner, the tax and the tip. This is going into more complicated, more adulting world stuff when we talk about simple and compound interest. So it's along the same line, but it's stuff that you will need as you get older. It'll make more sense. As you get older and get credit cards or start buying big ticket items like a car and you need to get a loan, these are the kind of things that will help us having a good background in it. So we're learning the basis of it right now. Yes?
Why do we need to learn it now?
So that way we're learning the stepping stones. We're learning the beginning of it now because it is stuff that we can handle as sixth graders. Just like how often do you go out to dinner and you pay for the whole meal and the tax and the tip on the meal? We're not doing that right now because we're usually going out to eat with our parents and they take care of it. But we're still learning about it because this is what we do. We learn about what's going to be happening, what information we need, what education we need. So having financial intelligence can help you make informed decisions that can end up saving you a lot of money in the long run. Start learning it now, so as things get more complicated in the future, you're not starting from scratch. Okay, so if we have a good background on this, it will help you as you get older. When you borrow a large amount of money from a bank or make a large purchase on a credit card, you are charged interest because, for example, $20,000 today won't have the same value by the time you eventually pay it back due to inflation. So if we look back at the cost of things, let's look at 30 years ago when I first got my driver's license. I could go and fill up my gas tank. However much gallons I put into my car was how much money I paid because gas was 99 cents a gallon. So if I had $5, I could put 5 gallons of gas into my car. It was super easy to figure out the math. It was that quick and easy. But because of inflation, things cost more today than what they did when I was a teenager. That's what happens. Things just cost more. People make more money. The jobs that people have pay more to help cover that inflation. If you weren't charged interest, the company you are borrowing from would lose money because you're paying them back what it cost 20 years ago, not what it costs now, because everything goes up in price. Even on small loans or purchases, charging interest is a way for companies to make money in general, because that's what they're about. Businesses want to make money. They don't want to lose money. They want to make money. That's why they charge interest. Interest isn't all bad, though. Money that is deposited into certain types of savings accounts can also earn interest for you. How many of you have a savings account? Yeah, there's a good amount of us that have savings accounts. And this is another reason why we're learning about it now. Because your savings account, you can be earning money on. You get interest. And different types of accounts, you make different types of interest on it. So your money is making money. Mario? So let's look at some of these terms that we need to know when it comes to interest. First thing is the principal. Now, this isn't principal like Mrs. Dawson is the principal of our school. This is principal that goes with money, and it's the original amount. So your principal is that original amount of money. It's the amount that you deposited into your bank account. It's the amount that you borrow from the bank. So it could be a loan. It could be a deposit. Whatever it is, it's that original amount. So loan, deposit, etc. Other things like that. The rate is R. The rate is the interest rate. So P is the principal, R is the rate, and T is the time. How often the interest is applied. So maybe every month you earn interest, every year you earn interest. It's how often that interest is applied. So we had two types of interest that we're going to be learning about today. The first one is our simple interest. So the interest is charged on the principal. Only. So you deposited $20,000. Every time you get interest, they factor what your interest is. It's on that original $20,000. So you're always working with the original amount, the principal. So there is a formula for that. It's the principal times 1 plus the rate times time.
When did you do that down below? Yeah.
I'm sorry, what?
Down below. In the example part?
It is. Mr. Schultz has it in both places. So you're right. So this is our formula. He had it written there, so I wrote it there. It's also down below. So you get to have it twice. It is that important to know. So we're going to look at an example of this. So let's say we're going to make a little table. We have the year. So maybe the year 0 is the first, your original. The first time you put the deposit in, the first loan that you take. Then we have year 1, year 2, year 3, 4, and 5. Then we have our balance. So let's say we put in, or we borrow $100. So our original amount, our principal, is that $100. So with simple interest, let's say we deposited $100 in those savings accounts that we have. How much money is going to be in that account after 1 year? So we need to find that interest. So we're going to put in what we know, our time, our original amount, and let's factor this out. So P is our principal, that's 100, times 1 plus our rate times the time. So we've got 5 years. We want to know how much is going to be in that bank account all the way up to 5 years. So we'll start with after 1 year. So our time is going to be a 1 because it's 1 year. What is the rate? Oh, I didn't give us all the information because I got confused with the formula being the 2 spots. So we have $100 deposit at 10% simple interest annually. Oh, this makes so much more sense. Now we have all of our information. Whew, forgot to write down the problem. We need that. So from that, I made my table. That $100 deposit is our balance. That's what we start with, the principal. 10% interest annually. So those are our key parts of our information. principal, our rate, and our time. So our principal is at 100, our rate is 10%, and our time is every year. So let's fill in our table or how we would do that. So let's come back. We know it's $100 is our principal. 1 plus the rate. What I'm not going to want to put a percentage in there. I want to put what math I'm going to do. So what would I put, Aiden?
0.10.
0.10 times 1, which is annually. That's every year. So I'm timesing it by 1. So if I use my calculator, we get to use calculators for this part of the test. If I use my calculator and I do 1 times 0.1, what do I get? Well, 1 times anything, 0.1. 1 plus 0.1 would be 1.1 times that by 100. So you do the inside of the parentheses. We do the multiplying first, then we add the 1 to it. Order of operations. Multiply, then we're going to add that 1. Then we multiply that by our principal. So what is 100 times 1.1? James? It's 110. So after 1 year, I have a 10% interest on that deposit. After 1 year, now I have $110. So just having my money sitting in that bank account, I'm making money on it. So now instead of $100, I have 110. So how much am I going to have at 2 years? What do you think, Gus?
120.
And how did you find out 120, Gus?
Because 10% of 100 is 10, so you keep on adding 10.
So, and if we did the math, this time instead of having a 1 here for my time, I would have a 2. Because it's after 2 years. So I'm using the same formula, but I had to change what my time was. Instead of being 1 year, now it's 2 years. So for my time, I had to change that to the 2. So it becomes 1.2. So 0.10% times the 2 gave me 0.2. And then we multiply that 1.2 times 100, and we get 120. Now we can see, after doing the third one there, we can see our pattern. Do I have to do the math every single time, or can I work the pattern? I could work the pattern, and I would know that at 3 years I would have $130, at 4 years I'd have $140, and at 5 years I would have $150, because I'm following that same pattern. But I can go and do the math and say, okay, 100 is my principal, times 1 plus my 10% times 5 years. Am I going to get 150? Well, let's work it out. That 0.1 times 5 gives me 0.5. So 1.5 times 100. 100 times 1.5 gives me 150. So I can follow, with that simple interest, I can follow the pattern if I'm having to fill in a chart. James?
On this one, can you only use your calculator to check, or?
Nope, you can use your calculator to do the math. Here's where the trick comes in. You have to be able to use the formula. So I'm not testing you on, can I multiply, can I divide? I'm testing you on, can I use the formula correctly? Do I know what my principal is, what my rate is, what my time is? I need to be able to work out the formula. So if you can write the formula correctly and then use your calculator to figure it out, that's fine. You have to be able to do the formula correctly. Does that make sense? So the simple interest, it's a little bit simpler to do, right? we can plug those numbers in and we get compound interest, a little bit more complicated. So I'm going to erase this so I can scroll up. And I really need us paying attention to what the difference is between compound interest and simple interest. So for compound interest, first I'm going to put back up here my simple interest formula. Okay, principal, rate, time, and how we work with that. Now we're going to work with the compound interest. It's not simple. Simple interest is simple to do. Compound interest is a little more complicated. So the compound interest is interest applied to a running total on the loan both the principal and accrued interest. So if we looked at that last example of that $100 deposit, and okay, after 1 year I had $110, and then I had $120 and $130. Now we're going to say, ooh, I had $100, then I had $110. Now I'm going to find what the interest is on $110. And then you find out what that would be at 2 years. So we have to combine the interest and the principal together. So let me show you how that works. Like I said, compound is a little more complicated. But once we know the formula and how to work with it, we can figure this out. So our compound interest formula is our principal times 1 plus the rate to the t power. So we're going to be using exponents for this one. So we still have our principal on the outside. We have the 1 plus, it's just plus the rates on the inside. So first we're going to do our parentheses. Then we do exponents. Remember, PERMDAS, parentheses, then exponents. So we'll do the exponent, then we'll multiply it by the principal. So it's not so complicated once you know where to put your numbers into the formula. Can we use calculators? Yes, because I'm not testing you on your multiplying and dividing. I'm testing you on how you know how to use the formula. So let's do an example for this one. This time I'm not going to forget our problem. So let's say instead of having a $100 deposit, we have a $100 loan at 10% compound interest annually. So remember when it was the simple interest, it was 100, 110, 120, 130, 140, 150. Let's see how this changes over time when it's compound instead of simple. So we're going to make our same chart. We've got our year. So we've got to start with our principal after 1 year, 2 years, 3 years, 4 years, and 5 years. Then we have our balance, starting with our principal of $100. So let's see how this works with the new formula. Again, we know what our variables are: principal, rate, and time. So if we look, our principal is the $100, our rate is that percent of interest, and our time is annually. We went up by 1 year every time. Yes?
So you do, if it's a loan problem, you would do that.
If it says that it's simple interest, you're going to do this formula.
Okay.
If it says that it's compound interest, you'll do this formula. Does it tell you what kind of interest it is? Yes. So it will tell you if it's simple or if it's compound. So you should know which formula to use. But you have to read the whole problem. First thing you're going to want to look for, is it simple or is it compound? Which formula? Then you're going to plug in your principal, your rate, and your time into the correct formula. So let's use our compound interest. Principal is $100 times 1 plus our rate. What is our rate? Emmett?
0.1.
0.1. That's 10% to the t power. Well, our first part of our table is 1 year. So I'm going to put a 1 right there. So this is one that well, maybe not quite so much this one since it's only to the first power. But you're going to want to, you're going to want to work this out on your own real quick while I answer the phone. Hello, this is Kate. He's in Nancy's. Yo, but. So, in your calculator, you would put 1 plus 0.10, right? So 1.1. One plus 0.1 is 1.1. So 1.1 to the first power. What would that be? Emmett? 1.1. Times that by 100. And what did you get? 110. So this one, it's the same right now. But now is where the tricky part comes in. Now we're going to do that principal is 100 because our principal is always the starting amount, 100. 1 plus our rate, 0.1. What changes?
The 2 powers.
The power. Because my time now is at 2 years. So, just like for the 1 year, I have that, but now I have a square. So before I can multiply it by the 100, I have to do 1.1 to the second power times that. So that's going to be 1.21. I'm going to times that by 100. And I get 121. So it's not an easy pattern to follow right now, is it, Evelyn?
Could we go into 1.31 next?
It's not an easy pattern. So instead of just saying, oh, I see what my pattern is, I can fill it in, I actually have to do all the math. So now this time, we're going to do 100 times 1 plus 0.1 to the third power. So I've got 100 times 1.1 to the third. So now I need to do 1.1. Do you guys remember how to do to the third power?
Yeah.
Okay, I heard somebody say no, so let me show you real quick. Because we have to be able to use our exponents. So, on your calculator, We have 1.1, and we want to go to the third power. So I need to go to my little caret there. Remember that little triangle pointing up?
Yeah.
Means I'm going to go up to my exponents. And I want to go to the third power. So that little thing there means I'm going up to my exponent. And I hit equal, and I get 1.331. Now let me go back to our page. If I can find it. Oy, 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 oy. Let's,
round to the 100.
oy. Why can I not get back to it? There we are, over here. So now I have 100 times 1.331. So if I multiply that out, I get 133.1. So when we're talking about money, we want to round it to that cent. So that would be 10 cents. So now we're at $133.10. So is there an easy pattern for us to fill in on this table? No, I have to do the math every single time. So now let's go, we're going to go over here and let's change this to the fourth power. Do it on your calculator and see if you can figure out what 1.1 to the fourth power is. What did you guys get? So we don't have to round it to money yet, not until the end. So we've got 1.4641 times 100. Right? Did you get 1.4641 when you did 1.1 to the fourth? I'm sorry, what?
Yeah, same.
Okay. If we took it one step at a time, you would get 1.4641 times 100, and that would give you 146.41. And some of us know how to type it all into our calculators all at once. That works too. So you could do it one part at a time, or you could put it all into your calculator, putting it in 100 parentheses 1 plus 0.1 parentheses to the fourth power. And if you hit equal with that, you get the same answer. So either way works. Some of us are more comfortable doing it step by step. Some of us want to plug it all in at once, one equation. Okay. Either way, you're going to get the correct answer. What I would need to see as you show your work is you have to show me what your equation is. And if you're plugging it all into the calculator, you would then tell me your answer. If you're doing it one step at a time, write it down so you know where your mistake happened. Okay? So do for 5 years, what would we get? Again, you need to have your full equation written out. Emmett, what did you get?
$169.05.
So when we put it in our calculator, we have out to the thousands place. And Emmett knew, oh, I'm working with money. I need to round to the hundredth because that's where my cents goes. So in your answer, you would round it to that 100th place. So you would know it was just 5 cents. So $161.05. So we have two formulas, one for our simple interest, one for our compound interest. So as we read our word problems, that's the first thing you're going to look for. Is this a simple interest or a compound interest problem? Which formula do I want to use? They're going to go back and forth. It's not going to be, oh, all of the first ones are simple, all of the last ones are compound. On the test, it's going to be mixed up. So you need to read for that. Let's look at our first problem and see if we can figure out what we're doing. Use the formulas for simple and compound interest to answer the questions below. Show your work. That is, show how you are plugging in the values into the formula you are using. So on this second page, here's what I would do. So I'm not constantly flipping back and forth. I would say, okay, for my simple, what is my formula? Principal? Aiden?
Principal times 1 plus rate and time.
And then I would go over here. Okay, compound interest. What's my formula for compound interest? Principal times 1 plus the rate to the time. So you can write those formulas above each of those words. Simple, compound. So now I'm not having to flip back and forth. On your help sheet for the test, should you write your simple formula and your compound interest formula? Yep. Good. So let's look at our first question. Shh. Stop talking, please. Your bank gives you a $1,000 loan to buy a jet ski and charges you simple interest. I would go right in there and I would underline or circle that so you know which formula you're doing. Okay, you want to make sure that you know which one you're doing. So simple or compound interest at 12% for 3 years. How much interest is earned on the loan? What is the total amount you will owe the bank? So there are two different things that they are asking for. So along with knowing that I'm doing simple interest, I know that my principal, they give me $1,000. That's my principal. So I'm going to put a P above that. 12% is what? Is that my principal, my rate, or my time? James? That is the rate, so put an R above that. Hello, this is Kate. Yes. Perfect. Thank you. I will let him know. All right. Yep. Bye. Mom said yes. You can stay after. All right. So 12% is our rate. So that means our time is 3 years. So you'll notice when I'm writing the time, I make it look like a cursive T with a little curl on the bottom, right? Because I don't want it to look like a plus sign. So when I'm making my T, I'm going to put a little curve on the bottom. So that way, if I make my T like that, sometimes it looks like a plus sign. And that's my way of differentiating between the plus sign and the T for time. So I'm going to put that little curl on the bottom. So now, which interest rate formula do I want to use? The simple. So I'm going to go to my simple. Say my principal is 1,000 times 1 plus my rate of 0.12 times the time of 3 years. So first thing I do is parentheses. Inside the parentheses, I still have to follow PERMDAS. So what's my first thing I do inside the parentheses, Evelyn? I'm going to multiply and then add it to 1. So if we're just plugging it all into our calculator, the calculator knows to do PERMDAS inside the parentheses. So if you plug it into your calculator, you would do 1,000 parentheses 1 plus 0.12 times 3 parentheses. And what would you get? Emmett? 1,300. Did you say 60?
Yeah.
So now we have to ask ourselves, which question did that answer? How much interest is earned on the loan, or what is the total amount you owe the bank? Aiden. Yeah, that's our total amount. We started with $1,000. Our total amount will be 1,360. So that's our total. How can I find out the interest? How do I answer that part, Mario? Yeah. 1,360, subtract out the original principal, and what's left is the amount of interest I'm being charged. So how much interest is that loan earning? Evan? 360. So when we're doing these word problems, you have to look at what answer you got when you did your formula. That's telling you the total amount. That's not telling you interest. That's your total amount. So to find the interest, you have to subtract out that principal. Does that make sense? Okay, so when you're doing the formula, it's telling you the total amount, principal and interest. So in order to get just the interest, you have to subtract out your principal. How are we feeling about this?
Great. Amazing.
Okay, so I saw a lot of thumbs up. I saw a lot of people nodding. So we have a lot of work time right now. So you're going to work this through. If you have questions, you're going to come see me with any questions you still have. Checking your answers. Oh, sorry, please stop moving. Checking your answers. If you want to check to make sure that you're doing it correctly, compound versus simple. Did I answer the question? Some of these questions had 2 questions in them. Some of the problems have 2 questions. Make sure you answer both of them. So when you come to your next one, you want to circle, is it compound, is it simple? You want to label what is your principal, what is your rate, what is your time, and then check to see how many questions do we have to answer. There are 2 question marks. I should see 2 answers. So make sure you're answering both questions on the test. If you only answer one question, it will be wrong. You need to answer the whole entire problem. Okay, so for my friends listening at home, we hope you are well. We hope to see you soon. Have a wonderful day.